Okay, so we're back for a regularly scheduled broadcast. For the first three problems, you need to refer to this chart that you should all have in your notes. And if you don't have it in your notes, you should put it in your notes. To figure out the end behavior of a polynomial, you need to know whether the polynomial is positive or whether it is negative. And you need to know whether the degree is odd or whether it is even. So these right here relate to the degree. This right here is the sign. And what you should have in your notes is that if it's odd and positive, then the end behavior will be down on the left and up on the right. If it's negative, that'll flip that around and make it up on the left and down on the right. If it's even, then both ends will be up. And if it's even and negative, then both ends will be down. Okay? So I am going to, as usual, ignore Emma, as difficult as it is, and ignore Sage, and help you guys go through this by giving you an opportunity to earn some dojo points right at the end of the semester here, okay? So, for the first one, let's turn to Alexandria. Can you tell me the end behavior of that graph? Is it positive or negative? Not the, yeah, the top one's positive. Is the highest exponent odd or even? Even. So positive even means that the end behavior is up, up. Okay? All right, how about the next one, Ariel? Is it positive or negative? Well, then you should open your book to page 311. Yes. Yes. And from now on and forever, Ariel, since you've exposed yourself as not being able to see the board from where you're sitting, oh, you should always have your book open then so you can follow along with the bouncing ball. So is number 2 positive or negative? Disagree? See how it says, okay. And then, good joke. I like your sense of humor. Like someone with a good math sense of humor. Is the highest exponent odd or even? Even. So since it's negative and even, what's the answer? Down, down. Very good. Sydney, were you, not Sydney, sorry, McKenna, were you wanting to answer the question or did you have a different question? Okay, sorry, ma'am. You don't get to. Okay, Danica, how about the last one? Down, up, okay? Okay, any, you got the bonus calculator. Any questions on those first three? All right, I'm going to give you a quick second. I know some of you probably, the good students, have started in on this already. And by good students, I mean, of course, Sage and Emma. This is where you are going to go through and figure out the differences. So 29 minus 159 is negative 130. Okay, I'm going to give you a second while I take attendance for you to keep working through that. You keep going until all the differences are You keep going until all of the differences are the same. Question? Well, it went down from 159 to 29, so it is negative. You go, Chris, you go this number minus this number. Okay? Okay. I think it'll still work out as long as you do that consistently. Okay? Have you done it yet? Okay, I'm going to give other people just a quick second who haven't done it to do it. Up first. Okay, McKenna, what's next? Okay. Okay, stop right there. All right, hold on. If you do not understand where McKenna is getting those numbers, now is your opportunity. Abby? Neither. Neither one. You go 29 minus 159. You go the second one minus the first one. So you know how when you're doing like the slope formula and it's y2 minus y1, it's the second y coordinate minus the first one? Same thing with this. And it's always going to be minus, okay? What? It does work the other way. If you just go 159 minus 29 and it just switches all the signs. So yeah, okay. All right, McKenna, keep going. 100. Minus 72. You have to go down 72 to get from 100 to 78. All right, so if you do this same process, 1, 2, 3, 4 times, the fourth time, touchdown Seahawks, the fourth time you do it, you get the same answers, okay? So that means when it says what is the degree of the function, it would be a fourth degree polynomial, okay? Okay, you what? Okay, so I don't like that very much. Yeah. What? Uh-huh. I don't know. Wrong class. Callista, what do you do first? Okay, so hopefully you guys all understand that your first step when solving these things, if you have something that's more than just to the first degree, you have a squared or a cubed or whatever, you got to get it set equal to 0, okay? Callista, what next? But before we do that, what can I factor out of each term? An x. Okay, so I'm going to go x, and then that bumps all of these down by 1, okay? Now that we have an x squared, that will allow us to now that you have an x squared, that lets you factor it into 2 parentheses, okay? So you've got x times x in the front. Then you need, hold on just a second, Callista, 2 numbers that, nope. Okay, what'd you have? Minus 9 plus 4, okay? Yes, ma'am, because you're going to finish it. So what makes this be 0? Shh, shh, shh. What? 9? Awesome. Okay, so those are your 3 answers to that problem. Okay, does that make sense? Yeah. Okay, staying there. Yep. Okay, number 6 is brutal. Okay. If there's a number 6 on the quiz, if there's a problem like number 6 on the quiz, it will be extra credit. It'll be for extra credit. Okay. Yes. Okay, so number 6, you start like any other problem. Set it equal to 0. Okay. But what you have to do is, yes? Yes, you have to, good. Recognize this as the difference of 2 cubes. So 27x cubed is really 3x cubed, and 8 is really 2 cubed. And so I gave you that printed out piece of paper with some different factoring strategies that looked a heck of a lot like this piece of paper right here. And the very last thing on the bottom says sum or difference of 2q. All right, so in this problem, since we figured out that these are the cube roots, this means that A is going to be 3x and B is going to be 2. Okay? So now we just follow that factor pattern. So that means this is going to factor into 3x minus 2 times a squared, which would be 9x squared, plus a times b, which is 6x, plus b squared, which is 4. Okay? So that's what that factors into. Okay? Yeah, I'll give you guys a second to... Is what? Yeah, we can't factor further than that, but we can solve. Yeah. Yes. Yeah. So, like I said before, this one is an easy one. If 3x minus 2 equals 0, what does x have to equal? 2/3. Okay, so that's easy. Sadly, when you use this sum or difference of 2 cubes factor pattern, this piece right here will never factor, okay? So you always have to finish it off with the quadratic formula, which is why I'm not going to require you guys to do this, but I'll give you extra credit if you can. Callista? How did I get this? Oh, I recognize that 27 is 3 cubed, and I recognize that 8 is 2 cubed. Okay? All right, so now we're going to go quadratic formula for this one. So opposite of b is negative 6, plus or minus the square root of b squared. B squared is 36, minus 4 times a times c, all divided by 2 over a, which in this case is 18. That's the quadratic formula, which you no longer have to memorize or have in your notes because it's written up in the front of the class. Okay? Then if I simplify underneath the square root, I end up with negative 36 divided by 18. But that's not so bad because you know the square root of 36 is what? 6. Hang on just a second, Callista. So the square root of negative 36 is 6i. So this would be negative 6 plus or minus 6i over 18. Yes, ma'am? Okay. Okay. So let's try this. First of all, I'm going to finish the problem. You keep writing it down. Okay. When you're done writing it down, Brennan's going to give you a hug. And then after that, I'll go back to the beginning and explain everything that I did. Okay. So for now, just sort of stay with it. Write the things down, but we'll get you to where you need to go. Okay? All right. Then since 6 goes into all of these evenly, I can write as my final answer negative 1 plus or minus I over 3. Okay? And so once again, I have 3 answers, 2/3, and then this plus and then this minus. Okay? Okay, hang on for just a second. Tell me when you're ready, Callista. Okay. I have 3x minus 2 equals 0, and I want to solve that for x. You just go plus 2, and then divide by 3. So that's where the 2/3 came from. Okay. Then this one, this one will not factor, so then we have to use the quadratic formula. So opposite of b, plus or minus square root of b squared, minus 4 times a times c, all over 2 times a. Okay? This thing simplified to be negative 36. Square root of negative 36 is 6i. The 6 because that's the square root of 36, the i because it's negative. And then since these three numbers are all divisible by 6, I divided them by 6. 6 divided by 6 is 1. 6 divided by 6 is 1. 18 divided by 6 is 3. Dunzo. Okay? You feel better? Okay. Good deal. Thank you for your patience, Calista. Okay, next one, number 7. This is a more important one. This one you will see every so often, so it is a good one to know. You can't factor anything out of it, and so your initial response is to do just like Emma and panic a little bit, because this is an x to the 4th, so what the heck? But what you should notice is I can factor it this way, except that since it's an x to the 4th, instead of being an x and an x in front of each parentheses, it's going to be an x squared and an x squared. And then if I just make that one little change, now I can just try to find two numbers that multiply to be 64 and add to be negative 20, which are, awesome, negative 16 and negative 4. And then you say, wait a minute, I recognize those. Those are two of my favorites. Those are the easy ones. Those are the difference of two squares. And so x squared minus 16 factors really easily into x plus 4 times x minus 4. And x squared minus 4 is the same thing. That factors into x plus 2 times x minus 2. Okay? Yes, bless you. Because if you don't factor it all the way, you can't figure out what the final answers are. But now that we have factored it all the way down, what makes this equal to 0? Negative 4. What makes this equal to 0? What makes this equal to 0? 2. So there are my 4 answers to that equation. Yes? Yes. So if you wanted to shorten up your answer a little bit, you could go plus or minus 4 and plus or minus 2. Okay? Nice job. Okay, let's, well, yes, you can get one of the answers pretty easily. But there's more than one. There's 3 because it's x cubed. So you got negative 5, right? Yeah, okay. All right, number 8. Not to stress anyone out again, but this is also an example of the very last one. This time it's a sum of two cubes. So that means we just have to make a little tiny little change. It's going to be x plus 5, and then it's going to be x squared minus 5x plus 25 equals 0. For those like 2 or 3 of you in here that are totally dialed in on this and sort of remember it already, there is a fun little mnemonic device to remember the signs. This one, yeah, so this one is going to be the same. So if this is a plus, then this is a plus. This one is going to be opposite. So if this is a plus, then this is a minus. And the last one is always positive. So SOAP is a little way to help you remember that. So same, opposite, always positive. That's not important. Don't get hung up on that. Because you guys can use your notes, so you don't have to memorize this. Yeah. No, I cube rooted it. Yes. Yes. Exactly. Yeah. Okay, good. Sophie? Yeah. Right. Okay, so then Sydney was able to get the easy one there. X equals negative 5. She just subtracted 125 from the very beginning and took the cube root, got negative 5. So that's a start anyway. But then to do this one, we have to once again use the quadratic formula. Okay? So, yes. Because 5 cubed equals 125. Because the factor pattern is it's a plus b times a squared plus ab plus b squared. Okay? That's okay. All right, so opposite of b is negative 5, so the opposite of that is 5. Plus or minus the square root is 25 minus 4 times 1 times 25. And here I go driving Callista crazy again and writing lightning fast. So I will wait. I will pause. How did I get that 4? I don't see if, oh, this one? That's always there. It's the quadratic formula. There's always a 4 there. Oh, thank you. And then divided by 2 times a, which is 2. Okay? No, a is the number in front of the x squared. And in this case, since it's 1x squared, a is 1. This 5 right here, because of the factor pattern right there, the middle thingy, whoops, that's supposed to be a negative. The middle thingy is a and b multiplied together. So since a was x and b was 5, the 5 is because 5 cubed is 125. Okay. All right, then I go 5 plus or minus. This inside simplifies to be negative 75 divided by 2. Yep, you're right. Negative 75 we can break down into negative 25 times 3. And again, the reason why I'm doing that is because I know the square root of 25, so that helps me. What is the square root of 25? What's the square root of negative 25? 5i. So this is going to be 5 plus or minus 5i divided by 3 over 2. And can't divide anybody by anything, so I am done. What? I should say yes, since you haven't been paying attention, obviously, because I've only said 3 or 4 times that there'll be extra credit if they're on there.
Yeah, but like you can have done that.
No, I will never require you to do that. Okay? Really, truly, yeah. Even next year. All right, number 9. Now we're back on solid ground. This is what we were just doing. This is what your homework was from yesterday. Use the remainder theorem in synthetic division to find P of 4. So what that means is put 4 in the box. And then I need to put the coefficients down. The only thing you have to be careful of, Callista, when you're doing synthetic division, make sure you don't skip any powers. So this is 2x to the 4th, so that gets a 2. But then there's no x cubed, right? So that means I have to put a 0 in there. And then this is going to be negative 3 and 4 and negative 1. Okay? So that's the easy way to stumble on synthetic division. Make sure you're including all of them. Yeah. Oh, what we talked about before? Yeah, do you want to do that? You're going to go? Okay. All right, so what's my first step? What's my first step? What?
That's 4 times 2.
Drop the 2, yeah. Okay, and then what's 4 times 2 is 8. 0 plus 8 is 8. 4 times 8 is 32. Negative 3 plus 32 is 29. 4 times, what? Okay, what's up? Like, oh, because you were gone. Yeah. Okay. Okay, Amy. So once we, do you understand how we wrote it out this way? Okay. So once we get it that way, we start by, like Eli said, dropping whatever this first number is that comes down. And then I just repeat through multiplying and adding, and multiplying and adding, and multiplying and adding, and multiplying and adding. Okay? Okay, sorry, I forgot you were gone yesterday. Okay, so what we just figured out is that if we took 4 and plugged it in for the x's here, you would get 479 as your answer. Yes? Not in this case because it doesn't say x minus 4 or x plus 4. It just says 4. Okay? If you are unhappy with what I have just done, you can still get this answer the old-fashioned way by just on a calculator replacing all of the x's with 4s and you will get 479. Or, here's a fun thing. If you're a little bit concerned about your grade, which some of you are, and you want to make sure that you get this right, you could do it both ways. And if you get the same answer both times, pretty good chance that that's right. But if you do it this way and you get one answer, you do it this way, you get another answer, you probably want to check your work. Yeah. You may use this review on the quiz tomorrow. Sorry. What? No final, just the quiz tomorrow. Yeah. Because that's what the original polynomial is. 2 times x to the 4th power minus 3 times, what's that? Yeah, I just plugged it in. And got 479. Yep, last number is your answer. So, Ashlyn, these two are the same. 2 different ways to get the same answer. Okay? What's that? Anna? Like, how did I get these, or how did I do the math? The middle. Okay, so I'm always, whatever the number is down here, I'm multiplying it by this one in the box. Because 4 times 8 is 32, and then negative 3 plus 32 is 29. So these are all adding, and these are all timesing. It's not. So just that's why I'm making sure you understand that you can still do it this way. Okay, Peyton? 479. No. No. Correct. Yeah. That is going to actually be on the test. Okay. All right, next one. You have several boxes with the same dimensions. They have a combined volume of determine whether each binomial below could represent the number of boxes you have. So now, Sophie and Brianna, since it says x minus 1, I'm going to put 1 in the box. Okay. What are the, because you always put whatever number will make that equal 0. Oh, that wasn't you? Okay. Okay, then same thing. I have 2x to the 4th. 4x cubed, negative 18x squared, negative 4x, and 16. This time I don't have a 0 because my exponents go 4, 3, 2, 1, 0. There's no missing spaces. Yeah. It's a positive 4x. Oh, you mean in the box. Okay. No, because it doesn't say x plus 4, it just says 4, okay? That's a little bit confusing. I agree, but that's how that goes, okay? All right, then we have just easy process from here. Bring down the 2, multiply and get 2. 4 and 2 is 6, multiply and get 6, add and get. I'm always adding these together and then multiplying with those. Yeah. So since we got 0 as a final answer, that means our answer is yes. You think someone threw up in the hallway? Are they out there or just a pile of cubes? Okay, just a second. No. I don't know, it's something dry. It's like busted up chalk or something. 2, 4, negative 18. Chalk. It's something, I don't know what it is, but it's... no, we have a couple more that we have to finish before we start the quiz tomorrow, okay? All right, so the next one is the same deal, except since it's x plus 2, we put negative 2 in the box. Okay, do it on your own. Tell me what you get. I'll tell you whether you're right or wrong. Yeah, it has to be 0 for it to work. Yes. On 14.